Hello students, I am Dr. Jadhav and I am here to explain the experiment thermal conductivity by Lee's method. So here one has to know what is the thermal conductivity. So thermal conductivity, it is a measure of ability of material to conduct the heat. So aim of this experiment is to determine thermal conductivity K of the bad conductor by Lee's method. So apparatus for this experiment are Lee's disc, stopwatch, steam boiler, 2 thermometers, micrometer screw gauge, vernier caliper and non-conducting disc. So diagram for this experiment is as shown in this figure. So here this is the hollow cylinder and this is the Lee's disc. In between the hollow cylinder and Lee's disc, the bad conductor is placed, and this is a steam inlet and this is steam outlet. This is thermometer T1 and this is thermometer T2. So formula required for this experiment is K is equal to m into S into d theta by dt upon pi r square into theta 1 minus theta 2 upon small d. So here K is thermal conductivity of bad conductor, m is mass of cylindrical metal slab, S is a specific heat of metal slab, d theta by dt is temperature gradient of theta 2. Now here theta 1 is steady state temperature of hollow cylinder after passing steam and theta 2 is steady state temperature of Lee's disc after passing steam. Here small d is thickness of bad conductor and small r is radius of bad conductor. So one has to know how to do this experiment. So in order to complete or in order to calculate the thermal conductivity of bad conductor by Lee's method, first one has to heat the water into the steam boiler. Here in this diagram steam boiler is not shown, and the pipe which is connected to steam boiler is connected here, that is to the hollow cylinder. So steam passes through this hollow cylinder and here is the steam outlet. So due to passing of heat from this inlet to outlet, this hollow cylinder, the temperature of hollow cylinder rises, and first one has to observe the steady state temperature at this 2 thermometer, that is thermometer T1 is inserted into the hollow cylinder and thermometer T2 is inserted into the Lee's disc. So steam is passed through this hollow cylinder up to which one observes the steady state temperature in this thermometer T1 and thermometer T2. That is the temperature above which the temperature cannot be risen for this hollow cylinder as well as this Lee's disc. So after reaching the steady state temperature, this bad conductor is removed. That is, here the hollow cylinder and Lee's disc come into direct contact, and after removing this bad conductor, this Lee's disc, the temperature of Lee's disc rises. So one has to observe up to 10 degree rise of this temperature of Lee's disc, that is temperature of this thermometer T2, and after rising this temperature of this thermometer T2, then one has to remove this hollow cylinder, and then one has to take the readings of this thermometer T2 after each 30 seconds, and one has to take these readings up to the steady state temperature reaches theta 2 minus 10 degrees Celsius. So up to which one has to take the readings after each 30 degree Celsius, up to after each 30 second. Then one has to take observations, that is time in second, and temperature, that is temperature of this least disk. After removing this after removing this hollow cylinder, after each 30 seconds, the temperature of this thermometer T2 will decrease, and one has to plot the graph, that is here time on x-axis and temperature on y-axis. So this is y-axis, this is x-axis. So this graph will show the exponential decay. So in this way one will draw the graph, and let's say this will, at this point, this is a temperature theta 2, that is steady state temperature. Then one has to take the point corresponding to this steady state temperature of the least disk at this curve, and from this curve one has to draw the tangent, and one has to take slope of this tangent. So this will give d theta by dt, and then one can calculate the thermal conductivity by Lee's method. So in this calculation, the specific heat of the concept of specific heat comes into picture. So one has to know what is the specific heat. So the specific heat, it is the quantity of heat required to rise the temperature of 1 gram of material by 1 degree Celsius, and its CGS unit is calorie per gram per degree Celsius. And after doing these much calculation, one may get the thermal conductivity of bad conductor. K will be equal to ... calorie per gram per second per degree Celsius. So this is the unit of thermal conductivity, which is a CGS unit. So we will see the setup of this experiment shortly. So this is the setup of Lee's method experiment, in which this steam boiler is this is the steam boiler and this is the heater, and when steam is created into this steam boiler, it flows through this pipe and comes to this hollow cylinder. Then this is the hollow cylinder, and this is the steam outlet of hollow cylinder, and from which steam is again flown through the flown out. And this is thermometer T1 and this is thermometer T2. This is the least disk and this is the bad conductor. And one has to measure the thickness of this bad conductor by using micrometer screw gauge, and the diameter of bad conductor by using vernier caliper. So when appropriate steam is flown through this hollow cylinder, then this thermometer T1 will show the steady temperature, which is indicated as theta 1, and here bad conductor is placed, and here thermometer T2 will show the steady state temperature, which will be theta 2. Now I have not flown the steam through this hollow cylinder. So both of these thermometers shows the room temperature. But after flowing the appropriate steam, the situation is observed that here the steady temperature theta1 is observed. That is the temperature above which there is no rise of temperature, which is the steady state temperature, which is denoted as theta1, and here it will be theta2. That is some steady state temperature. And due to placing of this bad conductor, some portion of heat is given to this least disk, and here also temperature is raised. So by observing this, after observing this steady state temperature, one has to remove this thermometer and as well as this bad conductor, and here when one will stop the flow of steam, the heat will be conducted directly through this hollow cylinder to the least disk, and one will observe the rise of temperature theta2 by 10 degrees Celsius. Then one has to remove this hollow cylinder, and again one has to place this bad conductor upon the least disk, and after removing this hollow cylinder, one has to take the reading of time versus temperature. That is, after each 30 seconds, one has to note down the temperature of least disk, and after noting the temperature, one has to plot the graph of theta2 versus time, and one has to plot the graph of temperature versus time, and as we have taken the reading, that is steady state temperature theta2, so from that point one has to draw the tangent and one has to take the slope of that tangent, and by using that one can calculate the thermal conductivity of bad conductor by Lee's method. So this is the observation table for Lee's method. Here after removing the hollow cylinder, one has to take the readings after each 30 seconds. So the first reading for 0 seconds, so one cannot take that reading. Then after 30 seconds, one has to note down the fall in temperature. Then after 30 seconds, that is for 60 seconds, one has to note down the fall in the temperature in T2 thermometer, that is theta2. Then at 90 seconds, there will be again fall in temperature, and one has to note down these readings up to the reading which is theta2 minus 10 degrees Celsius. That is, this must be the temperature at in this column, and up to which one has to note down these readings, and by plotting the temperature on y-axis and time on x-axis, one will observe the nature of graph will be this exponential decay, and if this is the temperature theta2, so at this temperature theta2, one has to draw the tangent and one has to take the slope of this tangent. So the slope will be nothing but d theta by dt, and by taking all the CGS units, one will get the value of thermal conductivity of bad conductor. So the result for this experiment is thermal conductivity of bad conductor, which is K is equal to ... calorie per gram per second per degree Celsius. So with this I will stop here. Thank you.